Hello friends, welcome back to my YouTube channel. In this class I am going to discuss what is the irreversibility of a process and ultimately I will solve a problem in which irreversibility of a heat engine will be calculated. Before starting, I must say one thing to all of you. Please do subscribe to this channel. Of course, like it and share it to your friends. Let's get started. So, what is the irreversibility? You know, irreversibility, irreversibility, which is denoted by I, of a work producing device like heat engine or turbine, etc., is nothing but irreversibility is reversible work minus actual useful work output of that device. This is the case of ideal heat engine. In fact, this is the work output if all the processes are carried out in a reversible manner in a heat engine, or you can say heat engine is a reversible heat engine between two specified temperature levels. If all the processes are executed in a reversible manner, then what is the amount of work produced, and that is nothing but the maximum work output between two specified temperature limits. This reversible work is nothing but the maximum possible work output if the process occurs between two specified states, initial and final states. And when this final state is dead state, we know that this reversible work is nothing but exergy. When the final state is dead state is nothing but the thermodynamic equilibrium state with the environment. So that's a different thing. Irreversibility of a work producing device you can define, that is the difference between reversible work and the actual work output, and it is always positive because in case of a heat engine operating between, suppose this is a source and this is temperature is Th and sink temperature is Tl, and a heat engine is operating between these two temperature limits. Heat engine is operating between these two temperature limits, and this is the work output. The efficiency of a reversible heat engine operating between these two temperature levels is the highest one, and work output of a reversible heat engine will also be highest between two specified temperature limits. But what is the work output of actual heat engine operating between these two temperatures? That we will calculate, and had it operated in a reversible manner, what would have been the work produced? And so irreversibility can be defined as wasted work potential. Suppose this is the maximum work potential that can be extracted out of this heat engine operating between two specific temperature limits. And if this heat engine would have operated in ideal manner, then the work output would have been maximum. But this is the actual case. This is the output of an irreversible heat engine operating between these two given temperature limits. So this difference represents the wasted work potential, or you can say this is same as lost opportunity to do work. So it would have produced this much of work ideally, but it has produced this much. So difference is irreversibility, and irreversibility is actually equivalent to exergy destruction. Irreversibility is equivalent to exergy destruction. Exergy destruction. You see, in case of a work consuming device like compressor or heat pump, etc., what happens? The work consumed is minimum when these work consuming devices operate in a reversible manner. In that case, if you want to calculate irreversibility, that will be WU in minus W reversible in. So since this is greater than this one, because had these work consuming devices operated in a reversible manner, the work input would have been least one, minimum, the least one. And in case of irreversible work consuming device, work input will be higher than this reversible work input. So this difference will always be positive. So irreversibility of any device is always positive, greater than 0. Of course, the irreversibility of a reversible heat engine or a reversible heat pump will always be 0. So we are now going to solve a problem on how to calculate the irreversibility of a heat engine. You see, the question is like this. A heat engine receives heat from source at 1200 Kelvin at a rate of 500 kilojoule per second and rejects the waste heat to a medium at 300 Kelvin. So the source temperature is 1200 Kelvin and the sink temperature is 300 Kelvin. And between these two temperature limits, a heat engine operates where the heat supplied to the heat engine is nothing but 500 kilojoule per second, or you can say 500 kilowatt. The power output of the heat engine is 180 kilowatt. The power output is 180 kilowatt. Determine the reversible power and the irreversibility rate for this purpose. So you see, all these energy interactions here are expressed in rate form. That means in power terms. These are power. So rate of heat input is given, rate of work output is given. But we are required to find out reversible power first and then the irreversibility. So you see, this reversible power we have to calculate. You know, between two given temperature limits, the efficiency of a reversible heat engine is maximum, and this is nothing but 1 minus sink temperature, low temperature expressed in terms of Kelvin divided by source temperature expressed in terms of Kelvin. And in this case, this is equal to 1 minus sink temperature is 300 Kelvin divided by source temperature is 1200 Kelvin, which is nothing but 3 by 4 or 75%. So this is the efficiency of a reversible heat engine operating between these two temperatures limits. But we are to calculate the reversible power produced. And this efficiency is nothing but reversible work output, or the work output of a reversible heat engine divided by heat supplied. This is the efficiency. So this is equal to W dot reversible work output of heat engine divided by 500 kilowatt. And 3 by 4, that means 3 by 4 is equal to work output of reversible heat engine between these two given temperature limits divided by 500 kilowatt. So from this we can calculate this is equal to 500 multiplied by 3 divided by 4 kilowatt. and this is nothing but 375 kilowatt. This is the power that would be produced if a reversible heat engine operates between these two temperature limits. But this is not a reversible heat engine because work output is given to be 180 kilowatt. So that's why there will be some irreversibility of this heat engine, because this heat engine is not a reversible heat engine, because the work output is as given in the question is 180 kilowatt. But had it been a reversible heat engine, between these two given temperature limits, its power produced would have been 375 kilowatt. So some work potential has been wasted. So that wasted work potential is nothing but a rate of irreversibility. Rate of irreversibility, which can be denoted by a rate of irreversible. Since all these energy interactions are expressed in power form, so this is rate of irreversibility, or I can say this is I dot is equal to W dot reversible output. That means work output of a reversible heat engine between given temperature levels minus actual work output between the given temperature levels. This is equal to 375 kilowatt minus 180 kilowatt, that is 195 kilowatt. So this is the irreversibility, rate of irreversibility of this particular heat engine. So reversible power produced is 375 kilowatt, but the actual power produced by this irreversible heat engine is, as given in the question, is 180 kilowatt. So the difference is the wasted work potential or lost opportunity to do work, rate of doing work, lost opportunity of rate of doing work, and that is nothing but 195 kilowatt. But you see, even in case of a reversible heat engine, if in place of this actual irreversible heat engine had any reversible heat engine operated between these two given temperature levels, it would have produced only 375 kilowatt at the expense of heat input of 500 kilowatt. So what about the rest energy? 500 minus 375 kilowatt, that 125 kilowatt of heat would have been rejected to sink. But you can't say that is irreversibility, because that heat is going to be rejected always. That is not a wasted work potential. So wasted, that heat rejected, some heat will be rejected even in case of reversible heat engine, and more heat will be rejected in case of actual heat engine. Here heat rejected is how much? Here heat rejected is 500 watt kilowatt minus 180 kilowatt, that is 320 kilowatt. But in case of reversible heat engine, less heat would be rejected to the sink. But that rejected heat to the sink is not will not come under the irreversibility. So irreversibility of a heat engine is the reversible work output that would be produced if a reversible heat engine works between the given temperature levels minus the actual work output of a heat engine operating between given temperature levels, which in this case is 195 kilowatt. So that's all. Thanks for watching.